Okay, so we have an algebra problem here with fractions, and we want to express in simplest form. We have 7 over 12x minus y over 6x squared. How do we do this? Well, this problem's fun because it reminds me of what we do with fractions in general, right? If I have 2 over 3, right, minus, let's say, I don't know, 1/5, one common algorithm is to say, oh, what is the common denominator here of 3 and 5? And usually the approach is in fact to find the smallest common denominator. But also what we could do is always just say, oh, well, if this is 3 and that's 5, if I take 3 and multiply it by 5, right, I get 15. So if I multiply the two denominators, what I always am going to get is a number that is divisible by both denominators, right? In other words, it becomes they're both factors, right? 15 is a multiple of 3 and 5. And this is nice because, well, that means I can just take the first fraction, multiply numerator and denominator by 1 altogether, or 5 over 5, which is 1, and multiply this one by what? Well, 3 over 3, or 1, because we want to multiply this to get the same denominator. So 5 times 2 is 10, over 5 times 3 is 15, minus 3 over 15, because 3 times 1 is 15, and 3 times 5 is 15. We just do this because now what happens is we have 10/15 minus 3/15, and that's 7/15, or our answer. In other words, whatever we're given, whatever algebra problem, whatever fraction problem we're given, we could always just multiply our two denominators to find a common denominator. And then what we do is, notice here, I multiply the first fraction by 5 over 5, which is the second denominator, and I multiply the second fraction by 3 over 3. And each of these 3's, right, that's the first denominator. So that strategy is going to help me in this problem. So it's not always a good idea just to multiply your two denominators. In fact, the best idea is to usually try and find the least common denominator. Now let's just go over that because that'll help us really understand this problem. Now if we have 1/4 and we subtract 1/6, I could multiply 4 by 6 to get a common denominator, but we do want to find the least common denominator. In this case, 12. Something they both have in common. So here that means I would multiply my first number by 3 over 3, not 6 over 6 like I did in the last one, and I multiply the second one by 2 over 2, not 4 over 4 like I would have done using the last strategy. I multiply them by the numbers I need to in order to get the denominators equal. That's it. Multiply each denominator by something so that they are both equal. And then just make sure you also multiply the numerator by the same value. So if I multiply this by 4, I then multiply the 1 by 3. If I multiply this 6 by 2, I do the same thing in the numerator. And then I get, of course, 3/12 minus 2/12, which is our answer, 1/12. So again, all I'm looking at in this algebra problem is the same thing. I'm saying, okay, I have 7 over 12x minus y over 6x squared. So I ask myself, oh, well, these are different denominators, but here I have a 12, here I have a 6. Can I multiply one by something to get the other? Yes, I can multiply 6 by 2 to get 12. That's my first hint. So I'm not going to multiply 12 and 6 and get 72. I'm going to multiply 6 by 2, right? So I get it equal to 12. I want those to match. Now I'm also going to multiply the numerator by 2 because, right, we don't want to change the fraction. 2 over 2 is still 1. It balances. But then I notice, oh, here I have an x and here I have an x squared. Can I multiply anything by x to get x squared? Sure, I can multiply it by x, right? Because x times x is x squared. Do the same thing in the numerator to keep it balanced. So we have 7 times x, or 7x, 12x times x, which is 12x squared, that's our least common denominator, minus 2y over 12x squared. And then we have our answer, 7x minus 2y over 12x squared. And we're done, right? We have choice 4 there. So the point is that when you have these algebra problems, compare the denominators. I look at the coefficients of each, here in this case 6 and 12, multiply one to reach the other. if possible. Otherwise, you'll just find the first common denominator with whatever techniques you have of the first number, and then the variables. Multiply one to get 2 to the other. In this case, it was x times x to get x squared. And then just do the same thing to numerators, and you'll have that least common denominator guaranteed. All right, thanks.